in this one, that section 6.7, the argument from continuity in the nervous system, this this is an interesting enough discussion, but it dives into the notion of analog computers, and I think probably for philosophical purposes, it's arguably it's interesting, but more for antiquarian interest. So I'm not going to discuss that one. The one though, 6.8, the argument from informality of behavior is an interesting one and quite relevant. And you do still hear this argument. It says something like this: you cannot possibly provide rules to govern all of behavior. And Turing said, yeah, sure, you're right, but he says, he wants to look at this in a little more detail. So he formulates the argument in a way that he admits is probably not quite the way it's typically put. And I'm going to simplify his discussion a little bit because he makes a reference to syllogistic logic and why the argument he thinks is faulty for a problem in syllogistic argument, namely about an undistributed middle, which again is interesting, but I'm going to avoid that. So I'm going to simplify his simplification of the argument, and I think it captures Turing's point, is that the argument that is framed in this is invalid. It's not a good argument, but not quite giving you exactly what Turing says, but maybe to dive more deeply into Turing's exact point here with its reference to syllogistic logic. It'll be a topic for another video, but now this will get the idea across. He thinks the argument is problematic. So here's one sort of way of phrasing, a little bit simpler than Turing, but I think captures his point. It goes something like this. The argument, and he thinks, remember, this argument's invalid. If humans have life-regulating rules of conduct, then humans are machines. However, humans don't have, by this asterisk, life-regulating rules of conduct. Therefore, because they don't have it, humans are not machines. These kind of arguments, we hear them often, and they sound good but they're invalid. It is often regarded as the fallacy of denying the antecedent. Now, what's the antecedent? Well, notice the structure. If then. If then, the first part after the if and before the then, that's the antecedent. Humans have life-regulating rules of conduct is your antecedent, and your consequent is humans are machines. And denying the antecedent is basically we're just putting a negation sign in front of this, saying humans don't have this, and therefore they don't. Humans are not this. This has this kind of form: if P then Q, not P then not Q. That's an invalid form. Not too sure about that. Think about if we substitute raining in for P and sidewalks are wet for Q. If it's raining, then the sidewalks are wet. Yep, when it's raining, sidewalks get wet. But if you say it's not raining, therefore the sidewalks are not wet, not necessarily. Sidewalks could be wet for other reasons, like somebody left a sprinkler on, the snow melted, a fire hydrant, variety of things. Somebody was washing a car, etc., etc. So in that sense, it's an invalid form. And he thinks that the informality of behavior takes this kind of a shape. But that's not all that Turing says. He actually goes a little bit more into detail. He does think that just because we don't have, but Turing agrees that we don't have rules to govern all of our conduct. He's perfectly fine with that. And he thinks that that's an easy thing for us, that life is big, messy, complicated, etc., etc. You're not going to have rules to govern all of it. So he's fine with that. But he wants to look a little bit more deeply because he doesn't think that that is going to mean that we're not necessarily machines, right? So what is he doing? He wants to dig into this notion of this sort of life-regulating rules a little bit. He wants to get a little bit into it. That's why he said there's an undistributed middle. So this notion of rules of conduct and its link with machines, he thinks needs to be examined a bit more. So what does he say? He says that we should look more closely at this notion of governing rules, and that there's two kinds. There's rules of conduct, those are precepts, like stop when the light is red. We're conscious of those. We choose to act on them or not, right? So you learn the precept when you're driving a car, you should stop when the light is red. You're conscious of that and you make a decision to act on it or not. Hopefully you do because it's the law, but you could not act on it or do something different. So we don't have precepts like that cover all of life. Life is more complex than that. Turing has no problem with it. But we do have rules, what he calls not rules of conduct, but rules of behavior. Rules of conduct are precepts of which we're conscious of, we act on. Rules of behavior are more like natural laws. And he gives one, like if you pinch a human, they'll squeak. In other words, if you put your hand, behavior. Here's a rule of behavior. You put your hand on a hot surface, like a hot burner or a stove or whatever, and your hand, the behavior will be your hand is pulled away. And as a matter of fact, you're not doing any thinking. Your hand is pulled away before you may even feel that it's hot. Why? Because your nervous system will pull your hand away, and it's connected up, and it's not necessarily processed through the brain like a conscious decision. He thinks so Turing thinks that precepts, our lives are too big in concept for precepts, but not necessarily for rules of behavior. We're governed by that. And so we're machine-like in that sense. And so in one way, maybe we can't talk about human life being governed by precepts. Okay, fine. But that doesn't mean we're not human, that we're not machine-like in the sense that we're governed by certain laws of behavior and natural laws. So it could very well be that we are, in the long run, all of our actions, all of our behavior in writ large is ultimately, Turing says, it could very well be under laws of behavior. That is, akin to laws like if you pinch someone and they yell, right? Or the hot stove and you pull your hand away. Maybe we're just vastly, vastly more complex. And so it's entirely possible that we are machines in that highly complex way. And so maybe, and again, this is speculating a little bit further than Turing, and maybe the notion of precepts and all these kinds of things, maybe that's only just something we think is the case, but ultimately underneath all of that, rules of conduct really are rules of behavior, and that's what we necessarily really are. All right, so again, that was a pretty rich and interesting discussion, and that bit about syllogistic logic where he thinks it's glaringly obvious, and I don't think it is. I think it's a thorny passage, and there'd be a lot of discussion. I've given you one way to think about it, but the important thing is that Turing thinks that this informality of behavior is not a good argument as to why we couldn't be machine-like in some way, because he thinks that there is a definite connection that we are, regulating rules of behavior makes us machine-like in some sense. All right, last one. I'm going to squeeze it in here. 6, 9, which is a really interesting one and a bit surprising when you read it. It's the argument from ESP. Yeah, extrasensory perception. Turing takes it very seriously. Not ESP as in mystical powers, but he thinks at the time, he says that telepathy, like mind reading, he thinks is statistically, as he says, is statistically well supported. And so he thinks that, if you bring this in, it's not a big step into believing in ghosts and all kinds of things. And so once you bring in the telepathy and things like that, it would seem that humans are not just physical creatures. That view of us as machines, physical creatures, becomes really problematic when you bring in the notion of ESP. Turing thinks this is a powerful argument, and he's concerned by it. He thinks that you can, you can do general relativity and physics and stuff without worrying about ESP. And so you can dismiss it in one area of science, but he said, we're not just doing any area of science. We're talking about thinking. And thinking may be bound up with ESP. Or an ESP, you might not be able to do a quote unquote science of thinking without looking at the notion of ESP. And so he thinks it could be very relevant. So the ability of the physicist to declare ESP irrelevant may not be a luxury that the cognitive scientist or the computer scientist has. And he even says in the imitation game, the interrogator could use this to spot the machine, right? The interrogator might, as the old ESP experiments might say, what is the suit of the, there's 4 suits in a deck, and what's the suit of the card in my hand, and the human with ESP powers, right, would get it right, let's say 130 times out of 400 instead of, the statistical 100, 1/4. And the non-ESP machine would simply guess and then probably get it right 100 out of 400. So a statistical average. But the human might have, we spot humans because of their ESP powers. Then Turing worries about the interrogator's psychokinetic powers might affect the random number generator. So this is another aspect of telekinesis, the ability to move objects and to influence at a distance using the power of the mind, not just reading minds, but influencing things over there with just the power of my mind. Again, it could be that the mind, has some natural capacity to do that, kind of like a radio wave or whatever. Turing thinks that, we'd have to be careful about that. And so he says, that might cause the machine to might not be able to guess better and more like a human, and so might not be able to identify the machine. Of course, with if you grant humans ESP powers, then the interrogator would just know through some clairvoyance or something that to be able to pick the machine out. He says, no matter what, if you take this seriously, as he seems to, with ESP in the mix, Turing says anything can happen. So if we do take this seriously, and again he seems to, you'd have to have a telepathy-proof room. So you'd have to screen that out so it doesn't influence the imitation game. A very odd little section. Probably Turing was influenced by what at the time there seemed to have been some results about telepathy. I think they've largely been debunked, but some people claim that there was some statistical evidence that some people could guess a little too well, and maybe they had some other kinds of power. Anyways, but that's definitely an interesting one, and again, kind of fun to read, but probably largely of antiquarian interest. Okay, so that brings us, so there's our 9 views. That brings us to the end of section 6 with our 9 views. All quite interesting, some antiquarian, some kind of strange. And then in this section on learning machines, so section 7, all right, the final section is on machine learning. So what Turing thought about it. He admits in section 7 that he doesn't really have good arguments in favor of his view that that machines can be thinking entities. And so he said, that's why I spent a lot of time attacking the other view. So he said, if I had really good arguments in favor of the machine thinking, the other section 6, would have been a lot shorter. So it's kind of an interesting admission. And I think that for what it's worth, Turing really is a time will tell in the answer to the question of whether or not machines can think. We just need for our computers to get better. And then he thinks, around 1950, he's thinking by the end of the century, we will pretty well know. So he expected that certainly people like us, well into the 21st century, this would have been a settled issue completely by now. And some of the things that we have today, he would have thought we would take as complete evidence of machines thinking, but not necessarily. So he really just ends this paper with a discussion of a plan for trying to educate a machine. And he thinks there are two routes to doing it. One is sort of the classical model of artificial intelligence where you're just programming, you're trying to program it in, and kind of like the chess playing computer model, right? Just making it where it can do really sophisticated things like that. And the other model is more of treating the machine of, as he said, making a machine with, quote, the best sense organs that money can buy, and then teach it English. So you almost raise the computer kind of like a child. But in the end, Turing doesn't make a decision as to which one is the better way. He thinks we should just, do them both, and we will see what happens. So the paper largely does not end up with a definite sort of, whether it's a time will tell kind of argument. Nonetheless, it's very rich and interesting, but I think at the end he's pretty convinced that it's only a matter of time before, computers are definitely playing the imitation game, and they're mixing right in with us. We can't tell the difference. And once you get to the point where machines are something that you can't tell, that's the main point, is that once they're in the game with us and you can't pick them out, the game's over, and nobody's really lost or won. It's just that it's all just a community now, and computers are a part of it.